So let's look at the subsequent part. If the normal to the curve at t square comma 2t meets a curve again at this part here, show that you're basically told to find the relationship between t and q. Alright. In other words, if what I did was I key in the equation of the normal that we found initially. So with the different p, we could actually find the different normal equation here. So just take note, maybe I should try and understand. So this part here, this is normal, right? You could just sketch this. To visualize this, I think what we need is this graph here. Then maybe I label it out for you. This will correspond to t equals to t, right? Yeah, and this over here will corresponds to q, which is actually the normal. It cuts at q, so this is what it cuts again. Okay, so this is aq squared. The parameter here is t equals to q, obviously. Now, I don't really like how they label it because it's a bit this t equals to t. If you want to know this point here, the parameter is t itself. It's quite confusing if they use the term t again, but anyway, this is t equals to t and this is t equals to q. That's pretty okay. Now this curve equation, we have already known this as y equals plus tx equals at cubed plus 2at. Now if this equation here, this line normal equation, cuts this again, meaning, very simply put it, meaning this will satisfy this equation. So what you need to do is actually sub the equation of the curve, the point here, and put it back in, right? So this case here, we're going to just substitute x equals to aq squared and y equals to 2aq into equation of normal. Okay, the normal that you found just now, this one here. So this case here, I'm going to sub into this equation. So that will be y, which is actually 2aq plus t aq square equals to a t cubed plus 2at. Great. So once this is done, we have a tq square. Actually, we could just divide, cancel off the a, right? It's easier. There'll be 2q plus tq square. There you go. Okay, so t cubed interesting. What's wrong here? Minus 2q. Great. So at a glance, obviously we need to, this is a cubic expression here. All right, so we need to find a solution to this equation here. Actually, very quickly, you could see that t and p are the same, t and q is the same. So we know that t equals to q is a solution. Actually, you can just get and check. So in other words, if you sub tq, so for example, if you sub t as q, you get q cubed minus q square q plus 2q minus 2q, this will give you 0, so this is a solution. You can guess and check as well if you can't tell that t equals to q is a solution, but generally that's a solution. So we know that t minus q is a factor. Okay, so we just need to use long division to solve it. So this case here, with t cubed minus q square t plus 2t, or maybe I just grab this as 2 cubed minus q squared plus minus, I could write this out. I'm gonna factorize the t out, okay? So this, I'm just gonna do long division, so t minus q here. This is a cubic expression here. So it's t squared. Okay. Minus q t squared. Then I'm just going to put minus q t. And then after which we're going to minus it out. Oh, sorry. This is a plus. So this is a plus. Normal long division will do. Obviously, you could use juggling method as well, but I'm just going to do what usually people do. So plus qt square minus this is qt square minus q square t. 2 minus minus is 0, so 2t minus 2q plus 2. Okay, so t square plus qt plus 2. Great. So this would be t minus q t square plus t square minus qt plus 2 equals to 0. Sure. Okay, that's how I do this question here proficiently. Any question or comments, please do let me know, and let's see how we can do the last part there.